Hello and welcome back to the shop. I know my videos have been kind of few and far between lately, and replies to comments on my videos have been even further in between. I found an issue where YouTube wasn't forwarding the comments to my phone, so I got that figured out, but I still have a ton I have to go back. I've just been super busy lately. We've been running around at work, doing a ton of work. The summer's been super busy and really hot and nasty. Which I'm not complaining. I'd rather have more work than I can handle than not enough work. So we've just been running around like that, and a bunch of other things in between. So within the next few months here, probably by September, October, we should start slowing down for the fall season at work, and I should have a lot more shop time. Today's little project here is we're going to make a set of T-nuts for this rotary table. This is an 8-inch Cushman rotary table that I was able to purchase off of eBay. It actually came in pieces, so I was able to get it pretty cheap, put it back together again. Thing works beautiful. And we're going to make some T-nuts for these slots. Now, there are a few ways that you can make T-nuts. Obviously, the easiest way is to use some sort of milling machine, whether it be a vertical mill or a horizontal mill. That's going to be the easiest way. But there are also other ways to get around making them if you don't have a mill. You can go at it by hand with some hacksaws and some files and make a really accurate T-nut that way. And you can also use a four-jaw and a lathe. Now, I'm going to show the mill, which is the easiest way. We're going to make the set here for this, and then we're going to make one using the four-jaw chuck and the lathe. The reason why I want to do that is because a lot of you guys, the first thing that you're going to go out and buy, or going to want to go out and buy, is some sort of quick change tool post. And those come with a blank, a big square blank that you have to machine for the slot on your compound. Now, if you don't, most people have the lathe but don't have a mill, which was the case in point when I bought mine, and you don't really want to kind of pay somebody to make it. So one option is to use the four-jaw chuck, and you can come out with a pretty accurate T-nut that works perfectly fine. And it doesn't quite look like a T, but we'll get into that when we do it. Now, the T-nuts we're going to make for this obviously aren't going to be hardened. You can buy T-nuts, but this is kind of an oddball size. So rather than getting a hardened T-nut and trying to machine it down, we're just going to make our own from scratch. And this way here, I can fit it perfectly to this the way I want. Now, they're not going to be hardened, which really isn't going to be an issue because this rotary table probably isn't going to see any heavy work and probably not much work in general. But we do need a set of T-nuts to be able to use this. So I dug up a piece of 3/4 inch square hot rolled stock that was hanging out in my scrap pile, and it's good enough for what we're going to do it for. So I'm going to take some measurements of this, and I'm going to sketch out a quick drawing so that we can go by it. And I'm going to bring you in here, and what I want to show you is a quick way an accurate way to measure slots without using any kind of internal micrometer or anything like that. So let's set up over here, and I'll show you how to measure these slots pretty accurately. Okay, so now what we want to do here is we want to measure out the T. So you can see we have the smaller slot here with, you can lift this up without squishing the fingies, the larger slot at the bottom. So now it's not too bad to measure the top here with calipers, but measuring the inside slot here, that larger slot in the bottom, is really difficult. It's hard to get in there, and you're not getting that much of a bearing surface, and it's nigh impossible to get into that slot here to get the height of that T. So now, and also we may want to use something that's a little bit more accurate than our calipers. So if you have an inside micrometer, one of the ones with the little legs, you can stick that in there, and you're all set and good to go. But those are relatively expensive, and we don't use them a lot, and so home guys aren't really going to have those. A cheap alternative is go out and get yourself a set of adjustable parallels. Doesn't need to be the name brand big ones. You can get a Fowler set for pretty cheap. And basically what they are is a set of wedges on a ramp, on a dovetail ramp. And you can see as I push them this way, they expand, and as I pull them this way, they get shorter. And we're going to use these as a transfer tool. These are great for measuring any kind of slots or little height differences, and some places where you can't get a caliper in there, just use them as a transfer tool. So right here I have a smaller one that fits this slot here. So we're going to put it in to that slot. We're going to close it up until we're nice and tight, tighten down the screw, pull that out. So now we can, even if we're using our calipers, we have a much better bearing surface. We can use our main jaws instead of rocking back and forth on these points and get a more accurate measurement. If we need to be even more accurate than caliper measurements, we can also get a micrometer and mic over it. Now with these, I can also get them down low enough to get into the height of the T there, which really isn't that critical on this because it doesn't matter, it's just clearance. As long as we have enough meat there for clamping force, that's fine. But I can also get the width of this T. I actually need the next size up. And I can actually get the width here of the bottom side of that T, which I was not able to get with these calipers. So these are really, really good. In all honesty, you're going to use these more for measurement transfer and things like that. You can actually use these as gauge blocks. You can set your micrometer. You can adjust this until you get a certain size. Set your micrometer to a certain size, and move these until you get that size, and then tighten them down, and you got yourself a cheapo gauge block. You're going to use them more in that capacity than an actual parallel, but they are an invaluable tool, and like I said, not too expensive if you go out and find them. I think you can get like a Fowler set for somewhere between $30 and $50, and you can find used ones online. Okay, so we got a little drawing here all marked up, and our stock is 3/4 of an inch. So I don't have to touch that because the slot is slightly larger than 3/4 of an inch, so I'm all set. I just need to take some off the top and take some off the bottom to square the top and the bottom together. So we'll probably just do equal amounts. So we'll take 65 off the top, 65 off the bottom. And this right here, we're going to be making them all together and just splitting them with the bandsaw after. So a 3-inch piece are going to be 3/4 of an inch wide, and these numbers here are to the centers of these holes. So once we find this edge with the DRO, I can just put in these numbers, and that'll be our holes. And these are going to be 5/16 18 threaded holes. It's the largest stud that I can get into that slot. Now the measurement, the only measurement that's really critical here is this side-to-side measurement here. You want to get that as close on the top of the T. You want to get that as close as you can so you don't have a lot of wiggle in it. The one measurement that really isn't too critical is this measurement from of this side of the T. Basically, we just want clearance. It just needs to be thick enough to be able to put a load on it. It doesn't matter if it's touching the bottom of the slot. We actually don't want it to touch the bottom of the slot. We want a lot of clearance in there, so if there's any schmutz in the bottom of the slot, these slide in really easily. So the height measurement here really isn't critical. The only thing that we need to that is this side-to-side measurement here, this top T, and the height from this larger section of the T to the very top. Because if that's too tall, it'll sit proud of the slot, which we don't want. We want that below the surface. So I'm gonna go cut off a 3-inch piece of this. We'll set it up in the mill, and we'll start hacking. Okay, so I'm going to take 65 thousandths off of both sides, and we're just going to do it by touch. We don't have to be supremely accurate with this. This is Niagara roughing mill. The number on is 43164, I believe. So we're going to try this out. This is one of the ones that was given to me. So I'm going to start this up. We're going to come in and touch. There's my touch. Set 0 on my dial here. I'm using a 1/2-inch end mill just so I don't have a color change in between. And we're going to take 65 thousandths. That's not a bad finish, plenty good for what we're doing. So I'm going to deburr this, and we're going to flip it, and then I'm going to take 65 off the other side too. Okay, so now I got to go down 325 thousandths, and I got to go in 160 thousandths. So I'll go down the 325. So there's 1, 2, 325, and I'm only gonna take. I'm gonna need a 160, so we're gonna try. Let's try 80 thousandths, see what happens. So first, I'm just gonna go in and I'm gonna touch. My touch is 0. There's 80 thousandths. We're gonna walk the table. Okay, now I was going to do the same thing with the back. Okay, so we got an edge finder in here. Actually, before we do that, let's just double check our measurements. We should be pretty close. I mean, this isn't ridiculously critical, so as long as we're not larger than the measurements that we have in that drawing, we should be good. So we're looking for 325 on this step here. Now you can see that we're getting exactly 325, and we're looking for 430 on this, and I'm getting 425, so we're plenty close for what we need to do. So this is a 200 thousandths edge finder. So what we're going to do is we're going to find this edge. So I'm going to bring it in. You're going to see it wobble. You'll see it straighten out. Then you'll see it, you may, from this angle or not, see it kick. Once it kicks, that means that we are touching the edge. You can zero our DRO then, and we move over half the distance or half the diameter of this this tip right here, which, like I said, is 200 thousandths. So we move in 100 thousandths, and we're right in on the edge there. So there's it straightened out. There's the kick. Try it again. There's the straightening out. There's the kick. I'm at the same reading. So we're going to go over 100 thousandths. Zero my DRO, and we know that's right on the edge. Now I need to find both sides of this. There's the kick. Clear that axis. Over the opposite side, find this edge here. Now I just need to half that reading, and we're in the middle. Okay, so let me get my drill chuck in here, and then we can get ready to drill. Okay, so we got our letter F drill in here. I'm not going to bother center drilling these things. I don't think we're going to need to. So I'm going to bring my DRO back here. I'm going to bring the x-axis back to my 0. So now the tip of that drill should be on this edge and on the middle of our part, which by eyeball it is. And we're going to go in 375 thousandths. It's 375 thousandths. So we're going to put our first hole right there. Okay, and our next one, 1 inch, 125 thousandths. and 1 inch 875 thousandths. And then 2 inch 625 thousandths. Alright, I'm just going to go back and tap those. I'm not going to power tap them because the taps I have are regular straight flute taps. Not really conducive to power tapping. So I'm just going to hand tap those and we'll be right back. Alrighty, we're tapped and everything fits. I just want to clean up the holes here. Alright, so I'll just go deburr, get a little bit of a burr right on the edge here. I'll go deburr this, make sure this is nice and smooth. And then all I'm going to do is scrap a line in the middle of each hole, and then I'm going to cut it off the bandsaw. I'm not going to videotape that because it's pretty straightforward. Okay, so we're pretty much all set. The only thing that needs to be done is just set up in the mill and just dust off the saw marks. But other than that, they all fit in there without binding, and they're below the top here, and there's no real wiggle in them. I think I have let's see what I got. Almost positive I got a 5/16 bolt. Yeah, so they fit in there all nice, and there's plenty of room to up and down vertically, but not much side to side there. So we're good. Alright, so now I want to show you how to make one of these using just a 4-jaw.